This is section 5 or chapter 5, section 2, formative assessment. To begin with the first question, to illustrate the relationship between the elements electron configuration and their placement in the periodic table, into what four blocks can the periodic table be divided? So to answer this question, it's better to have a look at the picture of the orbitals. So we have a periodic table. This is simply a rough sketch. So this is periodic table. We do have some parts. So these parts are noted by this one. So we have S block. Why it's S block? Because the last electron enters into the S sublevel, and this is the P block, and this is the D block, and this is the F block. So to illustrate the relation between the elements block, so it is in the answer will be S, P, D, and F block will be the answer. Question number 2. What name is given to each of the following groups of elements in the periodic table? But still better to see the periodic table. You have 18 groups. You have 18 groups. This is better to make it group 1 and 2. And this is, let me make it with different colors so that you will see the different sections. So these are the transition metal. So group 1 and group 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, 12. Here it begins 30, 40, 50, 60, 70, and 80. So if you see one by one, we can have the following situation. What name is given to each of the following groups of elements in the periodic table? So group 1. So this is our group 1. Group 1. Group 1. The name given is alkali metals. Alkali metals. Why it is alkali metal? Because these metals are very reactive. So when it reacts with water, it forms alkali or basic solution. And the second one is this one. The second part is this part. This part. We call it, this is A. And group 2 is, this is group 2. Alkaline earth metal. Earth metal. And group 3 to 12. Group 3 to 12 and 10. Here we may have to make it up to here 10, 12. This one, this region, from 3 to 12. This region called C, transition metals. Transition metal. Then group D, group 17. Group 17 will need one more electron to become 18. It is just the neighbor of group 18. So this is group 17. This is group 17. This is group 17. So D, we call it halogens. Halogens. genes. These are halogens are fluorine, chlorine, bromine, iodine. These are salt forming. Halogen means salt forming. It, they are well known. So very reactive non-metal and very reactive metal. Uh, and the group 18, so we can have this mark. Group 18 is this one. So group 18, which is our E, we call it noble gases. Noble gases. Why noble? They are very much inert towards reaction, so with little or no reactivity. That's why we call them inert. So these are what name is given for group 1 alkali metal, for group 2 alkaline earth metal, transition metal, and halogens and noble gases. So these are according to the question. Next question. What are the relationship between group configuration and group number for elements in the S, P, and D block? Question number 3. What are the relationship between group configuration and group numbers for elements S, P, and D blocks? Okay. For this one, the first one, if you see the periodic table again in a very rough sketch, this is the S, and this is the P, and this is the D. So if you take this condition and refer for what are the configuration and group number configuration. The configuration for this one, if it is the last electron must be in S2. And S2, and S1 and 2. It can be one electron or it can be two electrons. So it is better make it in this way. And NS1 up to 2. It can be NS1. If we further split this into group 1 and group 2, the last electron ends with NS1, and this electron ends with NS2, which means S block, and the group number is indicated by this one. When it comes to, so for S you have two options. One is NS1 and one NS2, which means the electron number can be from NS1 to NS2, which is S. The P is known from NS2 because the P comes after S, so the S must be filled. So, and P can be 1 up to 6, which means NS2 NP1, NS2 NP2, NS NP3, all these are indicating the P block or the configuration. So if you add these two numbers, 2 plus this number, we better take example here. Let's take oxygen 8. Oxygen is 1s2, 2s2, 2p4. NS2 means this one, and NP means again this one. So the group is simply you add 2 plus 4 is equal to 6. So directly it is group 6 using the representative elements, or you just subtract from group 16, from group 16 minus 10, or it is 16 minus 10, which is group 6. So this is the indication. And in the case of D block, how can you separate the D block? The D block has a configuration n minus 1 d n s 2. D can be from 1 to 10. So this is the configuration. So if you want to take example for this, you can take example like scandium, which is 21. So 21 is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. Now we are going to focus on this part. This part has a pattern. This is n minus 1 d, which is 1, and this is n s2. So it doesn't matter, we can switch the order. This is energy order, but this, if we shift it to the other side, if you bring this one here and d in front, it will be in shell wise. Energy shell, first shell, second shell, third shell, and fourth shell. So energy wise, 4s comes before 3d, so we have this arrangement. So to know the group number is simply add the electrons here in the 2, add this electron, which is 2, plus, and the electron of this one, which is 1, which is group 3. Group 3, scandium group 3 means this is 1, this is 2, and this is 3. So scandium is here. So these are how you can exactly locate the elements in the periodic table by relating with their configuration. Number without looking at the periodic table, write the outer electron configuration for the group 15 elements in the fourth period. Okay, group 15, which means it is in terms of main groups. So group 15 means it is we have it is a p block element. It's a p block element. 1, 2. Here are from 3 to 11 here. Then no 3 to 12. Then 13, 14, 15. So we are dealing with this one. So it is p block. It is p block. So the last should end with p block, and the arrangement include 4 shells. So let's keep on configuring. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4s2. Group 15 means it is the valence shell will be 5 electron, which is group 15. So group 15 minus 10 from group 15 minus 10, which is the transition metals, it can be given, it is group 5A. 5A. So 1A, 2A, 3A, 4A, and 5A. So to know 5A, that you must add the electrons in the outermost shell. So 3P, this is the first fourth shell, because it says group 15, the configuration of fourth period. So to know the period, you must have the fourth shell. But if we stop here, we don't have 5 electron in the valence shell, or group 5. It will be group 2. So I have to keep on. 3p6, 4s2, 3d10, and 4p to be 5, it will be 3. Now we want to focus on this part. So if you rearrange this expression, we end up with 3d10 10, 4s2, 4p3. So if you add these 2 electron, and 3 electron, which is 2 plus 3, 5. This is it. So in the fourth period, this is the fourth period. So the answer will be, the final answer will be this one. 4s2, 4p3, and 3d10. This will be your final answer. So without looking the fourth period, so we end up with this one. Next one, 5. Without looking at the periodic table, identify the period, block, and group of the element that had electron configuration. In the first place, this configuration has a pattern. Focus on this one. It has the S and D is related by n minus 1, D7, and NS2. If a configuration ends up with this pattern, it is a transition metal. So this configuration indicates it is a transition metal. So we have already argon. Argon is 18. 18 plus 7, 25. It is 27. So what can we say? Period. To know the period, simply this is fourth period. So 3D argon, 3D7. Sorry, here we have to write it properly. Argon, this is written in the form of noble gas notation. Argon, using a noble gas notation, 3D7 4s2. So this, the fourth shell, this indicates period. The fourth period. So period will be, it will be in the fourth period. So the element is in the fourth period. And block, it is D block. It is in D block. D block, why? Because it has a pattern transition metal, or D block. So D block. The first one is here, the second answer is respectively. And the third one is the group number. So to know the group number, add, to know the group number, group 9. Group 9. How? Just add 3D7 4s2, add the 2 electrons, these 2 electrons, 7 plus 2, which is equal to 9. So this is the group number. The last question. Elements in the period 7 contains elements in the S, P, D, and F blocks. Suppose that there were a period 8, it contained elements in the G block, where G had the angular momentum quantum number L is equal to 4. Means, if you remember L is equal to 0 is S, L is equal to 1 is P, L is equal to 2 is D, L is equal to 3 is F, L is equal to 4 is what? Let's say G. If a hypothetical element in period 8 had an atomic number of 120, into what group in the periodic table would the element fit, and what properties might it have? So you can simply, an element that had atomic number 120, if we configure it using this arrangement, So an element, the answer will be an element that had the atomic number 120 would be in group 2 and would have properties similar to the properties of the other alkaline earth metals. So if it is an alkaline earth metals, so the element will be it's metallic. Alkaline earth metal is characterized by alkaline earth metal is characterized by it is metallic. What else? High boiling point. It has got high boiling point, melting point, and they are less reactive than alkali metals. So this is how we can describe or characterize in terms of physical and chemical property of alkaline earth metals. They are metallic as compared to the metallic nature, which is less reactive than group 1 or alkali metals, but they are more active than the transition metals. So these are the points.